Good evening, South Africa and the African continent. My name is Dan Matsapola, Science Engagement Manager at the South African National Space Agency. I'm in the Earth Observation Division. Welcome to the 22-year celebration of South Africa as an African spacefaring nation. History changed on the 4th of October 1957 when the Soviet Union launched successfully Sputnik 1. The world's first artificial satellite was about the size of a beach ball, 58 centimeters in diameter, weighed 83.6 kilograms, and took about 98 minutes to orbit Earth on its elliptical path. 42 years later, on the 23rd of February 1999, tipping the scale a whopping 20 kilograms lighter, South Africa launched its first miniaturized satellite, a major breakthrough accomplished by a group of postgraduate engineering students at Stellenbosch University. Today, the 23rd February 2021, we celebrate 22 years of South Africa as an African spacefaring nation. This webinar focuses on the Sunsat Satellite Mission, its heritage, and contribution to the anatomy of the South African space industry. With me on the panel, I have 4 panelists, highly acclaimed and captains in their own right in the space industry in South Africa and globally. I will start with the bio of Dr. Sias Mostert. Qualifications: B.Eng in Computer Science from Stellenbosch University, 1987. Masters of Engineering from Stellenbosch University, 1990. International Space University, 1992. And he has a PhD in Engineering from Stellenbosch University, 2001, as well as an Executive MBA from University of Cape Town in 2010. Dr. Sias Mostert is former Associate Professor at the Engineering Faculty of Stellenbosch University with over 16 years of professional experience in lecturing. He is currently the Chief Executive Officer of SCS Aerospace, working with customers on complex satellite and science and technology solutions and strategy along 3 lines of business, namely missions, constellation partner, and solution provider. He believes in building a sustainable future through space-enabled technology. He has a keen interest in bridging the digital divide with space technology and is passionate about using space technology as a catalyst for development. He has a deep understanding of technical satellite engineering experience combined with successful program management and execution. Industry success: satellite subsystems delivered to Australia, Germany, and other international missions. He was the development manager on Sunsat in 1992. Strategy and program development for small satellites from 1998. Sumbandila Sat, mission coordinator at Stellenbosch University, 2005. He is the co-founder of SCS Holdings Pty Limited from 2008. Prof. Sias Mostert has been introduced, and now I will move on to the lady who has helped to put Sunsat into outer space. Wanda Harding is a senior missions manager in the Flight Project Office of the Launch Services Program at NASA's Kennedy Space Center in Florida, providing leadership in launch services, project planning, development, analysis, and forecasting. The LSP serves as the bridge from Earth to space for the NASA and NASA-sponsored science, exploration, and technology demonstration missions. These missions, as described by then NASA Administrator Charlie Bolden, enable us to explore new worlds, develop more innovative technologies, foster new industries, increase our understanding of the Earth, expand our presence in the solar system, and inspire the next generation of explorers. As a mission manager, Harding leads and manages a matrixed, multidisciplined mission integration team of senior level engineers and business management personnel located at Kennedy Space Center and at Vandenburg Air Force Base in California. She is the mission manager for the upcoming Mars Science Laboratory, MSL, and the Tracking Data and Relay Satellite, KNL, missions. Harding's prior mission management experience includes during various phases of formulation and implementation, the secondary payload missions, Mostert, Sunsat, Manin, and Citizen Explorer, and the primary missions, Spitzer Space Telescope, Gravity Probe B, Ocean Surface Topography Mission, Aeronomy of Ice in the Mesosphere, Demonstration of Autonomous Rendezvous Technology, Dawn, Interstellar Boundary Explorer, Lunar Reconnaissance Orbiter, Lunar Crater Observation and Sensing Satellite, LCROSS, Landsat Data Continuity Mission, and the Solar Dynamics Observatory. Prior to joining LSP, Harding held a variety of technical positions in the Space Station Launch Site Support Organization. She participated in the NASA Administrator's Fellowship Program, which included a one-year teaching assignment at Spelman College in Atlanta, Georgia, and a professional detail at NASA headquarters in Washington, D.C. Harding also served as an executive intern with the director of Kennedy Space Center. Harding is a graduate of the Benjamin E. Mays High School Academy of Science and Mathematics in Atlanta, Georgia. She earned a BS in Electrical Engineering from Hampton University in Virginia and received her MS in Electrical Engineering from Georgia Institute of Technology in Atlanta. She joined the NASA team and Kennedy Space Center in 1994. So welcome, Wanda Harding, to the panel. And it also gives me great pleasure to introduce the Chief Executive Officer of the South African National Space Agency, Dr. Val Munsami, who holds a PhD in physics, a Master of Business Leadership, a Space Studies Program Diploma, and a certificate in International Air, Space, and Telecommunications Law. He worked in South Africa's Secretariat for the Non-Proliferation of Weapons of Mass Destruction, managed the implementation of a suite of bilateral and multilateral science and technology agreements involved in the development of South Africa's national space strategy and national space policy, and oversaw the establishment of the South African National Space Agency that he heads today. On winning the bid in 2012 to co-host the Square Kilometer Array, SKA, the biggest radio astronomy project in the world, he became the chief specialist for astronomy and African space science. In this role, he led the development of South Africa's multi-wavelength astronomy strategy and the SKA readiness strategy for Africa, and conceptualized the model for the Pan-African Space Science University of the African Union. He also chaired the African Union Space Working Group, which was tasked with the development of the African space policy and the African space strategy that was approved by the African Union heads of state in January 2016, and also facilitated the implementation plan for the African Union Science, Technology, and Innovation Strategy for Africa, STISA. As of January 2017, he has been appointed as the Chief Executive Officer of Sansa. He is currently a member of the South African Council for Space Affairs, SACSA, and was the Vice President of the International Astronautic Federation, IAF, but currently chairs the IAF Administrative Committee for Developing Countries and Emerging Communities. He is inducted as an academician of the International Academy of Astronautics, IAA, and sits on the advisory boards of the Space Generation Advisory Council and the United Arab Emirates International Space Congress. He also chairs the Committee of Heads of Organizations of Research and Technology cohort, which comprises of 21 science and technology institutions in South Africa. With that, we welcome Dr. Val Munsami to the space panel. And last but not least, I will introduce Mr. Mutivi Ramusi, hailing all the way from the Capricorn district of Limpopo province. Mutivi is a graduate from Essex University, Colchester, United Kingdom. Other qualifications include a BTech H&D in Electronic Systems Engineering, Essex Institute, now Anglia University. BTech National Diploma Electronic Communications Engineering, London College, 1988. Senior Executive Leadership Program with GIPS in 2001. International Executive Development Program, Vets Business School and London School of Business in 2016. He has held positions at, including but not limited to, Cell C for yourself, Department of Communications, SMMT Pty Limited Online, SAB Green Tech Telecommunications, CSIR Satellite Application Center, South African Telecommunications Regulatory Authority, SATRA, that later merged with the Independent Broadcasting Authority to establish the Independent Communications Authority of South Africa, ICASA, 2001 to 2003, and finally Transnet. Currently, he's the Chief Information Officer at National Lotteries Commission, and his projects include establishing the first ever MPLS, fiber-based wireless access network for the Commission, interconnecting all provincial offices, establishing and implementing an Oracle ERP fusion platform, as well as an overall technology refresh program. The South African Institute of Chartered IT Professionals has certified Mutivi with enterprise systems analysis and integration as a competency. With that, we welcome all the four panelists on my panel, and I would like them to reveal themselves to the audience. So I will start my first question as we celebrate 22 years as an African spacefaring nation. I will start with Professor Sias Mostert. Prof, tell us about the Sunsat mission. What was that all about, and what was your involvement in that critical mission?
Thank you, Dan, for the opportunity to reflect on Sunsat. It brings back so many incredible memories. So my first role on Sunsat was started, in fact, in 1991 when I was assigned a piece of the communication software on Sunsat. And then in June 1992, I had the privilege of being the first South African to attend the International Space University. It's a 10-week program that I can highly recommend if you want to transform your life. And on returning from there, I immediately changed from academic position to an engineering position at Stellenbosch University and became the development manager on Sunsat. Now, what was interesting at the time is there was no budget, and that's why the position was still available. I said, that's not a problem, we'll find the budget. And it turned out that in the end, Sunsat was built on a really low cost budget. And when we complained once to an American colleague about it, he said, be glad you'll have a low-cost mission. So we were in it for the long haul. The other benefit of not having a budget is that nobody can stop you. Remember, 1992 to 1996, South Africa was holding its breath. So there was not a lot of things happening on a grand scale because people were waiting for the big transition. So there's a benefit of not having a budget. You can't be stopped. But so Sunsat was a result of, it's really an educational project. And if we count from 1991, Sunsat today actually celebrates 30 years of education. and education for very highly skilled masters and sometimes PhD of mechanical engineering, electronic engineering, software engineering. And in total, I've made some sums here. If you add into the 155 students that came on board, around 2,000 from the Department of Communication, the Sunsat project to date has graduated in the order of 320 students in a senior degree in engineering, one way or the other. But Sunsat was really possible because a number of people joined the university at the same time, which didn't know that at universities it's all about the individual, and they came from industry. So in industry, it's all about the team. So Professor Garth Milne, which Wanda Harding asked about earlier, he came to Stellenbosch University, and he did his PhD at Stanford, where he saw the space flight laboratory, and he said, but why can't we have a laboratory at Stellenbosch University? So we created the Electronic Systems Laboratory in 1994, where everything happened in terms of Sunsat. Then there was a Professor Christopher Yoon. Now, Christopher Yoon, he's a bit older than the rest, but he's essentially the guy that appointed. He was a dean of engineering at some point, but he essentially appointed the key other professors, which opened up the doors to being in the team. Then Professor Jan du Plessis. He never completed a PhD, but he doesn't need a PhD. He's still called professor because there's nothing that could stop him. As I said, after 5 rectors, who's going to stop him now? So he was a key guy. He was, in fact, the person that appointed Professor Garth Milne. And then Professor Herman Stein, who is just retired at the end of last year. He was a key stakeholder in the Sunsat team. And in the end, he worked in the UK and he came back to South Africa. And then Professor Arnold Schoonwinkel, he also came from industry. And he's today, I think he's at the point of maybe retiring in the next year or 2, 3 as a vice rector of the University of Stellenbosch. So it's these 5 professors and myself, which actually were the catalyst to make Sunsat happen. And I recall that there was a German professor coming to visit us, and he counted 1, 2, 3, 4, 5 professors working together. No, this is impossible. This is impossible. So, and it was really that team effort. And I was young. I mean, I was good 15 years younger than any of the other people. So it was that team which made it possible. So in 1992, after ISU, I got a very broad education into multidisciplinary introduction into space. And I was privileged to win a prize for the so-called design competition. And the prize was very interesting. It was come and visit NASA headquarters and Goddard Space Flight Center and meet anybody you like. Okay? Wow. So eventually I made myself to get there to Washington, D.C., and Dr. Jerry Soffen was the author of the prize. He has also since passed away. He was a PI on the first Mars missions. He then took me to all the people that he thought was important. I said, we're looking for a launch opportunity for Sunsat, I said. He said, well, let's go here in a back room somewhere. And I'm trying to remember the person's name, but Don, his first name was definitely Don, and I'm not sure whether his surname was Brown. But anyway, there he was, working on the Argos mission, and there was a piggyback satellite called Oersted from Denmark. And he asked me, how big is your satellite? I said, this is size. He says, well, it fits in here. And it's not the normal piggyback size for the Delta II, because in this case the main satellite was a Air Force research satellite. There was a special mechanism or a cantilever, well, a pipe, if you want, and there was little bit more space attached next to that than's normally the case. So we said, well, you fit in. Let's do some sums. And we looked at the sums, and it says, fantastic. And at the time, there was also, and this is really important, space is not a solo mission. It's a global effort. At the time, there was some good reasons why America wanted to have some space relations with South Africa, and Sunsat was it. That was available. So Sunsat got the prize for being available at the right time. And NASA said they can offer the launch. And of course, now that triggered an educational experience of note. Because now it's an Air Force, the primary mission is the US Air Force, you know the US Air Force. They're serious about their space stuff. Anyway, so there we were. So eventually, when we started the discussion, the launch contract was again. Of course, I was alone there in Washington, and they said, "Well, they want to see the other people. Are we a team? Do we have some?" So they came and visit, and they came to visit Sunsat at the time, Stellenbosch University, and it was contracted for launch in October 1995. Now, the only thing about research missions is that their launch dates are unpredictable. If you look at the James Webb Telescope for today, then you will see a mission that has similar characteristics. It will go up one day, but not soon. So we started working on Sunsat, and the first engineering students were taken in, master students. They did some courses, they did some design work, and every 6 months there was a delay of 6 months. Now, the first time it's not so bad. Second time you say, yeah, interesting. But by the third and the fourth time, you need to figure out new ways of motivating people and how to get things done and things like that. So we learned a lot about how to manage expectations. But inside the satellite, there was quite a bit of complexity. So I'm just going to touch on some of the subsystems and how it played out. So the satellite has got solar panels. And the solar panels were professionally procured. We actually had to pay for solar panels because they have to have a certain capacity. But the batteries we got for free from NASA. And these batteries, by the time we got them, they were 16 years in cold storage. But they were a spare set of batteries for another mission. So they were very well looked after. By the time we launched them, they were 20 years old. So imagine launching batteries, building your own mission, but they were for free. That's where we could afford them. And the whole power system of Sunsat, and we can come back to that. There's 3 bigger, larger computers and 9 small microprocessors on the satellite and lots of other things. The whole power budget for Sunsat was 20 watt. So imagine 20 watt. Today, in today's term, you can switch on 2 LED lights with that. This was the whole power budget. Okay. So it really sharpens the mind in terms of optimizing for very scarce resources. So the main item on Sunsat was the camera. And the camera, I remember the optics for the camera and in fact the focal plane was supplied by the CSIR. So we worked very closely with the CSIR for 29 years, in fact. And this camera, I remember this camera was spotted by Professor Garth Milne because it resolved the hair on the lion's face from a long distance away. He said, wow. This is a good camera. This is a good camera. Anyway, so we flew the camera. It's so in that our 64 kilogram satellite, we achieved 12 meter resolution. So our blocks on the ground were 12 meters by 12 meters. In 64 kilogram. In today's technology, you can achieve 12 meter resolution with a 6 kilogram satellite. 10 times less. Okay. So if you take pictures, you have to store them somewhere. So we had a very large mass storage on the satellite, a whole 64 megabyte of storage. It consumed a whole big subsystem. Today, in that 6 kilogram satellite, you can launch 128 gigabytes of memory. So things have moved along. And then the satellite must actually point somewhere. You must be able to. I mean, if you look at the image, let's say it's 30 kilometers by 30 kilometers size of the image. Then and you think about the satellite being 500 kilometers away from you. Yeah. How accurately must you point the satellite? I mean, try and take a picture from Cape Town of the traffic crossing in Drie Sisters. And that's the problem. That's the problem you're trying to solve. So So pointing the satellite is really important. So that it's called the attitude determination and control system. That was the speciality of, in fact, 4 of the people on the list of professors that I've mentioned. Most of them got their PhDs in that domain. So it's really one of the core competencies. So we created the attitude determination and control system. I think Professor Herman Stein led the effort. And today, 22 years later, we have 2 export companies in South Africa exporting attitude determination and control systems. So if you just keep on developing the people, the industry will follow. The industry will come out. Then there's a computer system on the satellite. In this case, we had essentially in dual redundancy. We had, for those people that's for a throw from the past, there was a 386 and a 186 on the and the transputer on the satellite, and another 9 microprocessors. Today's computer systems are also have a whole host of microprocessors and maybe 1 or 2 main processors. Then there was a very, very good communication system. You needed to be able to talk to the satellite. I remember Garth Milne speaking, using a handheld, a small walkie-talkie, to actually communicate with the satellite. And it was finally launched in 1999, the 23rd of February 1999, after many launch attempts. It launched on the 11th attempt, and I'm not going to talk about the launch further. And that's more or less, and it worked for almost 2 years. It was a very bad, it was a free orbit, free launch, and there's no such thing as a free lunch. So the price for the launch was that it's not in a very good orbit for the camera. For Sunsat, it was a very bad orbit. The orbit was designed for Ørsted, and Ørsted wanted to survey the magnetic field, and so they wanted to be everywhere. They wanted to be everywhere in terms of altitude. So it was an elliptical orbit, and they also wanted to be everywhere in terms of time of coverage. So for some periods, for some months at the time, Sunsat was in the sun all the time, and there's no way to cool it down. And we suspect that was the demise of that sun for a couple of months on the batteries, which were 22 years old by then. After 2 years, that actually led to the demise of Sunsat. But we brought back all the science payloads, science data that we wanted to achieve, and yeah, Africa got into space. Thank you.
Wow. Thank you, Prof. That is wonderful reflection point. I mean, I was reflecting on my own Stellenbosch experience of 2000 with the people you are mentioning. And that was fantastic. Thank you very much for that. And I'm sure our audiences will derive maximum educational value from your presentation as well. Now, Sunsat was built, now it's ready. And I almost wanted to ask you, but this will be in the next round. Why couldn't they just have a WhatsApp call back to South Africa to see the other team members? But then that's just a good joke, okay? Wanda, please come and tell us a little bit about how the Sunsat was launched in the United States of America and what your role was.
All right, so good evening. And again, it's a pleasure to be here. Congratulations on the celebration. NASA's role was basically getting the satellite from Earth to space. And as the professor mentioned, he had the opportunity to come over to the States, meet some people at NASA Goddard Space Flight Center in Maryland and at NASA headquarters. And as we were reflecting on the mission, I had an opportunity to speak with Karen Poniatowski, who played a very instrumental role in identifying a launch vehicle that we could actually assign for Sunsat, which was the secondary payload mission to go along with Ørsted on the Delta II. So I'm going to share, oh, and also as an update, I have transitioned myself from NASA, and I'm now a high school physics teacher here in the United States, but I was asked because I was there for the launch and came on board as we got ready for the launch campaign to see Sunsat off. So I'm going to share my screen just so that we can kind of highlight and see, well, what is this Delta II? Where was Sunsat? What did it do? How did we get it to orbit? And so the first thing with finding a ride to space, of course, is finding a launch vehicle that will be able to take it. And so for this mission, we used what was called the Delta II 79-2010 launch vehicle. And the designation basically means that we have these 9 augmented boosters here to help get the launch vehicle off and make sure that we're able to put the spacecraft into the right orbit. This is considered the second stage of the launch vehicle, and this is attach fitting for the primary spacecraft. So this was the US Air Force launch vehicle. You'll note that Orsted was placed on this side of the vehicle atop the second, as a part of the second stage, and Sunsat was placed here. And when you're riding as a secondary payload mission, what happens is the focus is placing the primary spacecraft in its orbit, and we have what's called excess performance, which basically means there's additional fuel left that if we need to do some additional maneuvers or as it goes through its own depletion, then we're able to reorient and provide orbit injection for the secondary missions. And as the professor noted, the Orsted, and I'm sorry, I'm at school.
That's okay. That's okay. It's part of the job.
Okay, pardon there. There was an announcement there. But so as he mentioned, Orsted basically drove the launch placement for the secondary mission. So Sunsat was there along for the ride. As a part of preparing the launch vehicle and satellite integration, there's a series of tests and analyses that have to be performed, basically to make sure that the satellite can survive the launch environment, and also that we're able to appropriately match and couple the launch vehicle and spacecraft together. And so what I want to share next with you, so once we have the launch vehicle mated with the spacecraft, then I am going to flip here. This was actually, I found in my old archives. What we have is here, just the cartoon image of the flight profile, and forgive us because in the States, we were still using our American units, and so you won't see the kilometers referenced here, it's nautical miles. But we did launch from Vandenburg Air Force Base, and as you can see here, just kind of takes you through each phase of the launch itself, from the liftoff to the ejection of the solid motors that are here, separation of the first stage, and now you see that the second stage is being ignited. The fairing, which serves as a protective covering while it's doing the initial launch phase, is ejected, and you see a series of maneuvers that we take the second stage through so that we can place the primary mission in its orbit and then subsequently the secondary mission. So if you want to follow along, this is California Vandenburg Air Force Base, and we have a series of tracking stations. This was actually an aircraft vehicle to help us monitor and follow the vehicle telemetry so that we can make sure that the launch vehicle is behaving as designed. And we follow on along. You can notice as we come up from California, you'll recognize Harderbeestock as one of the, there we go. Harderbeestock is one of the tracking stations here. So that has always been a part of NASA's history when it comes to being able to track our satellites and vehicles. Makes its way on around, and finally separation of the Sunsat spacecraft occurred approximately in this location here for item 10. And so when it comes, as he mentioned, there were a series of delays initially caused by the readiness of the Air Force mission. But then once we got to California for the actual launch at Vandenburg, we ran into a series of delays, combination of weather, issues with the launch vehicle, and of course, by the, as he mentioned, I think it was the 11th attempt, we were able to successfully lift off and place Sunsat in its orbit. One final thing that I want to mention here is that it's interesting how we move forward in technology and time. I'm going to stop sharing here, is that one of the roles that I had, there were a series of people that worked with the Sunsat mission prior to its getting to Vandenburg, performing some of the tests. There was a crew from Goddard that actually came over to Sunsat to perform the separation test, where the adapter that's mounted to the launch vehicle has one piece, and then there's the side of the spacecraft that connects to it. And we do what's called a separation test, which is basically to make sure that when the bolts are released, then the spacecraft can be successfully ejected from the launch vehicle. And so you test out that system real time. And so NASA sent a team over to South Africa to support some of those activities. And there were basically NASA headquarters kind of secured the partnership for the launch. In exchange for the launch, there was data exchange that we got from Sunsat. That was the way we kind of worked the deal. Goddard Space Flight Center played a significant role with working with Boeing, who actually provided the launch vehicle, making sure that the documentation, identifying all of the interfaces between the spacecraft and the launch vehicle were in place, the testing and the analysis. And then our role at Kennedy Space Center came into play more so once we got out to the launch site, making sure that the facilities were there for the payload to do its final preps, and then going through the actual integration of the launch vehicle and the spacecraft. One of my jobs also included, on the actual day of launch, we literally had strip charts that received the telemetry. And so we were responsible for verifying appropriate and successful separation of the spacecraft. And I do recall actually looking and seeing the blip on the strip chart that indicated that the bolts had successfully fired and Sunsat was placed in its orbit. So it was a historical moment. I remember a large group coming over from South Africa to take witness and be a part of the mission. It was something that NASA was proud to be a part of as well. We have international partnerships. The International Space Station is one example. We've worked globally with other countries for spacefaring type missions. And so to be a part of the historical launch of South Africa's first satellite was a big deal for NASA. And as I said, I'm now a high school teacher, but it was one of the first missions that I had the opportunity to be a part of when I was working with NASA. And so it was exciting to be invited to participate in today's event.
Oh, wow. Wanda, during this kind of moments, you just realize the value of education, the value of an educator. And thanks for agreeing to work with me and South African teachers. Of course, I'm twisting your arm because I can do that. Okay, you for all of that. I'm going to move along now, and just to encourage audience to put your questions into the Q&A function. I'm going to move along to Dr. Val Munsami, a man who has how far, where he was, and the context behind how he got to be where he is. Dr. Munsami.
Thanks, Dan. Let me just stop sharing, then you can see me. Thanks for the opportunity, and quite excited to be here. Can you hear me?
Loud and clear, Dr. Munsami. Go ahead.
Maybe I'll tell you the story of where I was as part of the presentation. Presenting. Just a second. Right. Okay, I'm going to do a sort of a retrospective reflection of what Sunsat actually means for So, our satellite build program started in the 80s, essentially. And we had a satellite called Green back in the days. But the interesting thing is, and this was called GreenSat, but it was never actually launched. But there was a number of experts that worked on that program, and they got into the university, Stellenbosch University, and that's how Sunsat was born, the whole program. And I think Sias is one of the experts that came from that genesis, essentially. The interesting thing about the Sunsat program, and given that it was a university-based program, and as Sias had mentioned, the big focus was on human capital development. And so you saw a number of postgraduate students being developed in the process. And we saw over 70 or so masters and PhD students. And I'll come back to what that means, but I'm just giving you the timeline as to how this landscape evolved. And based on that heritage of Sunsat, we then had the second, or let's say the first government-sponsored satellite called Sat. And that was launched in 2009. And the linkage back to the Sunsat program, there's two things. One is the heritage. Secondly, apart from the human capital, you had a company being sort of siphoned off from the university called Sunspace. So this was the first semblance of an industry development starting to happen. So Sunspace was essentially contracted to build Sat, but still somewhat in partnership with Stellenbosch University. So you see the evolution moving from human capital development at a university to now looking at an industry focus and seeing government now coming in and funding the satellite. As Sias had mentioned, there was no funding for Sunsat from the government perspective. Yeah. Around about 2009, when Sat was launched, and I'll come back to the next slide, there was some movement based on what had happened around Sunsat to start building a space program. And you'll see in the next slide, we started working on the space policy and the space strategy. But just around that time, the Cape Peninsula University of Technology approached the department. And by the way, I was in the department at that time. I think it was the Deputy DG for Research, Development and Innovation. And they made a presentation of starting a CubeSat program at CPUT. And that in itself is a genesis for all the CubeSat missions that came through. And so South Africa also has heritage around the CubeSat mission. So we saw Zakube 1 in 2014, Zakube 2 in 2018. And then there was two South African satellites as part of the QB50 mission. And Sias is one of the contributors to that from the SES perspective. And again, Stellenbosch contributed as ZA Aerosat, which was part of the QB50 mission. And based on that heritage, we were then looking at a subsequent development called EOSat-1. Now, where we are with the EOSat-1, it's currently under review, and we're looking at cost-effective ways of actually completing that. But you can see we moved from human capital development from university perspective to industry development, and then looking at the genesis in terms of military focus now to civilian focus. So based on that landscape, and if you look at how the clock ticked from, let's say, 1994, when South Africa won its democracy, before that, there was a military focus. And as we were making the transition, there was a big focus on non-proliferation, because at that time, South Africa had nuclear weapons, and it had a launch vehicle program, and it had the satellite development program. So as you tone down on the nuclear weapons side, you had to forego some of the technologies, including the launch vehicle or the launch capabilities. And as a consequence, the big focus was on non-proliferation, and there was a Space Affairs Act that was introduced around about 1994, which is around demilitarizing some of these capabilities and controlling dual-use technologies. But as the time clock ticked, around about 2008, there was a number of policy shifts. So the Department of Science and Technology was established in 1996, when the democratic government realized that science and technology was very key for the socioeconomic development of the country. So science and technology was established in 1996, and that policy landscape sort of evolved, and we were working on a 10-year innovation plan. And from that context, we started to work on a national space strategy, national space policy, and the focus then was on space for socioeconomic development. And then we started to look at extending the current act into make it more user-friendly in terms of now moving to the industry focus. In fact, last week, we had a new bill taken to what we call the clusters, and that was approved last week and is going to cabinet for repealing the Space Affairs Act, which was more on the military focus, now looking at promoting space from an industrial focus. And you can see the Sunsat program is somewhere between 1994 and 2008. And it sort of moved that clock, helped to move that clock to where we are today. And just in terms of the growth perspective, I'm looking specifically from a Sansa perspective. 2-3 years ago, our budgets have been sitting around 150 million Rand. Today, we've seen a significant growth of around 350 million rand. In the next year or two, we're probably staring down at about plus minus 14 billion. And I think we've made the announcement around the space infrastructure hub. So we're still going through some bankable feasibility studies and whatever, and trying to firm that up. And even tomorrow, we're sitting with government departments and talking about a SATCOM strategy and trying to finalize that. And we're also working with the likes of Centec around the SATCOMs strategy. And I must mention that we also in discussion with NASA around hosting the 4th deep space network here in South Africa. And we've done the environmental impact assessment for that site, which will be in Mikersfontein in the Western Cape. And because of the transition, the political transition in the US, the decision has gotten delayed. We were expecting a decision actually this month. So if you sum up all of those initiatives sort of coming through at the moment, you're looking at about 14 billion. Now you can see the significant growth of the space sector as we stand. And you have to ask yourself, sort of looking back, what sort of role did Sunsat play in all of that? And so here's my reflections in terms of how I see Sunsat, and given where we are today, given the growth and how the landscape is transforming. First of all, it is the genesis of our space heritage. It's the first mission that went to space from South Africa. So it is a landmark in terms of a milestone for our space heritage. Because of the heavy focus on human capital development, it saw a human capital development pipeline or human capital pipeline. Even some of those experts are still in the system at universities, training, working in industry and so on. So that's quite an important aspect in terms of the capacity we have as a country today. We also saw the birth of our space industry. We saw Sunspace coming, being morphed out of the university as a private sector company. We saw technological advancements. Sias gave you some examples of how some of those technologies were actually exported to other countries. The next issue is around space confidence. I mean, we could go into global platforms and speak about space in a much more confident manner because of that heritage that we had. So for example, we were one of the co-founders of the group on Earth observation, together with the US, European Commission and China. So we are the 4 co-chairs on the group of Earth observation. If you look at the Committee of Earth Observing Satellites, we chaired Sias around about that time. And when you hear about data democracy, that was an idea that actually came from South Africa. So that gave us the confidence to speak about space in a more expert sort of manner rather than speaking at it from a novice point of view. And we also saw the burgeoning of SMEs, small, medium enterprise. Sias spoke about 2 companies coming out of that pipeline, looking at ADCS, Attitude Determination Control Systems. There's quite a few other companies that we can count that came out of that pipeline. And then we saw the seed for the growth of the space sector. I've shown you how the sector has grown and is still growing quite significantly. And so all of that, you can sort of look at it from starting from the Sunsat. And then we also see the foundation for a new space era. So all that growth is actually built on that foundation of the human capital pipeline, the heritage that was developed through the Sunsat program, and obviously the industry focus that stemmed out of that program. So I think in terms of where we are and many of the professionals that work in the South African space sector, I think we can owe a lot of where we are now based on the Sunsat heritage. Thanks, Dan, for that and for your attention.
Wow. CEO, thank you for that comprehensive context-setting presentation. Thank you very much. We really appreciate it. And I think the young people for whom this celebration is really intended, seeing that Africa is sitting on 420 million young people aged between 10 and 35, I think they can begin to see why investment in education is critical, especially the ones who just got their results yesterday, and in the provinces, you can see they are going today and days to follow. Thank you, CEO, for that. And I will go now to a man who will wear many hats, but he represents the industry that we talk about, ZASpaceInc, the industry body, but he also was involved in the satellite ground station, and he's a telecoms ICT man. Mr. Mutibi Ramusi, let me give you an opportunity to share with the audience just your perspective on Sunsat and the days that led to the 22 years where we are today. Is Mutibi still there with us? I know he went to charge his device earlier on because he was running out of
I'm here.
power. Ah, Mwetapili, please take us along.
I'm here. Thank you very much and good evening to all the viewers, and thank you to Sansa for the opportunity to come and share the very good experience that one has gained in the space of satellite. I think to all the participants, you've heard that all the previous speakers, everybody that spoke before me, my role in this journey, I worked for a company. At the time, it was Satellite Application Center, which was a division of the CSIR. And that center, I think it's very important for those that are viewing and participating to know that Africa prides itself that we do have a telemetry, tracking, and control ground station in South Africa. This satellite center, application center, has supported a number of missions. As you know that for any satellite launch, you've heard what Wanda was talking about. It's very critical that during the space launch, you have stages where your investment is taken care of. And that's the center that I was heading in the early 2000. Now, in relation to what you have heard, I'm now going to close the link from all what the presenters have said. Now, from a policy point of view, you've heard that Dr. Val Munsami, the CEO of Sansa, spoke about the role that government played. Where I chipped in, I was then seconded to the Department of Trade and Industry. Now, knowing very well that when you deal with space, there are nations that are participating within the United Nations, COPIOS and all other structures. Now, we had to make sure that in any country where there's a space program, you need to have a space council, which kind of like it's a regulator that takes care of all policy related matters, so that as and when you talk about launch of satellites, they are backed up by well-researched policies. So the DTI, very well at the time, because it was even looking at the trade and industry, it was to make sure that how do we bring in all the SMMEs, as Val has said earlier on, and some interested parties in the value chain of space. So we had to make sure that as part of growing the industry, we grow at an inclusive space sector, because, you know, space, like any other sector, it cannot just be left to the few. So from a policy point of view, my role and with others was to make sure that we put the groundwork and we put actually the foundation that will support the growth of Sansa and many other space programs. Again, in partnership with the Department of Science and Technology then, because names have changed, it was more about how do you bring innovation in this process. So you've heard from the panelists, they spoke about the birth of Earth observation. Now, Earth observation was a strategic intent for government to make sure that when you look at regional planning, this starts with municipalities, it goes with rural development, it goes with many other sectors like your agriculture. We know that remote sensing plays a very important role because visual aid, it's key in terms of decision making, so that you can have proper models to do proper predictions. So Earth observation became the main driver of our program. Then the third leg, which I wanted to share, was more about this transformation that I said. As you indicated in your introduction, I am participating in the ZASpace with the industry. I'm responsible in looking at how space can transform the economy of South Africa. We know that in the space program, and I'm glad today we're talking about the Science Festival, and we're looking at how space has contributed to human development. Now, if you don't transform the very same people that you want them to appreciate the role of space, we are now looking at how to bring in people from rural areas. I come from a rural village in Butokwa, in Limpopo. People, when they talk satellite, there's always thinking about spying of people, spying of countries, but they don't see the value. So this is what we are now going to be transforming. And in partnership with Sansa, it's one way of saying bring space closer. And one of the biggest transformation, Dan and panelists and those that are watching, is the issue of bringing curriculum. Remember, if we're talking about transforming a human mind, it starts at schools. So we're even calling those who are watching the webinar tonight, if you've got innovation of coming up with some of the basic animation that shows how space are launched, satellites are launched, it's becoming a very important subject at schools. It starts at preschool, it goes up into university. It's going to be key. The final one, which I thought I need to share, the excitement. In today's world, Dan, we're talking about partnership. You cannot work in silos. Now, space program, like as Val spoke and Prof spoke, and Wanda. Remember that satellites, many people still talk about cost. Now, we need to find a way that as you celebrate today, how do we bring the mobiles into this space so that when we look at the end results in terms of cost, we don't see space as a barrier for development. So I'm very excited. I just thought, let me share those 4 pillars, which I'll say it's policy, industry growth, transformation, partnership, and making sure that we reduce cost. But most primarily, it's human capital development, as all my panelists have said. Thank you for the opportunity. Thanks, Dan.
Thank you very much, Mtivi. We truly appreciate those contrastings. I was encouraging the audience to send the question and answer through the Q&A function, and I noticed that there is only one comment in the Q&A. Hi all, not a question, but I was working at the CSIR SEC at the time when Sunsat was launched, and was impressed with the images we downloaded from Sunsat. Although it was South Africa's first EO satellite launch, makes me proud to be part. That was Johnny Rizos. Okay, our long-standing veteran there who just left Sansa into the space industry. If there are no questions that are coming through, I'm going to propose, in the interest of time, because I did make provision for 20 minutes in the end for Q&A session. I'm going to ask some very interesting questions. One is going to go to Professor Sias Mostert. Just briefly, in 2 minutes, tell us about the transition from being a university professor to becoming an entrepreneur who actually started his own business. And today you are the CEO of SCS Space. That experience, Wanda, please prepare yourself, because I'm also coming to you with a question on transitioning back into education. And then I'll get to other panelists after.
Thank you, Dan, for a very good question. So I can give you a number of short answers. So remember, in 2000, spin out innovation companies from universities was not the norm. It was quite new, and I remember our negotiations with Stellenbosch University. We were all doing Braille management, finding our way. But what I can say about space industry is that it is more difficult to build a space company than to build a satellite. So so it is, and in the case of a country like South Africa, where there is a lot of other high technology industries, the manpower is available. But at the end of the day, the market, you need a big enough market to be able to operate in and maintain critical mass. And as incredible as the growth trajectory that has been shown by the Sansa CEO into the near future is so dismal it was in the past 20 years. So every step, every piece of progress was made based on very hard work in the international market. And imagine trusting companies in the world procuring satellite components and satellites and sub-satellite subsystems from South Africa. It takes a long time to build your reputation to the point where you see today people ordering thruster systems from South Africa for their next generation satellites. But it's a 20-30 year journey. It doesn't happen overnight, and it is it requires lots of teamwork.
Thank you very much, Prof. And I hope that that is an encouragement for the young budding entrepreneurs out there who are looking to break into the space industry. There's a lot of work that goes behind the scenes. Wanda, I give you 2 minutes to tell us about the transition you made. What was the main driver of that? What was the main driver of your decision to go back to developing human capital?
So one of the things that I enjoyed doing while I worked with NASA was outreach, visiting schools, sharing what we did at the agency, kind of bringing it to the classroom, and coupled with the fact that teaching is something that I've always wanted to do. So a few years ago, I decided to make that leap. I went back to school for education and jumped right into secondary education, working with high school students. So it was a pretty easy decision. I do miss working with NASA, but I'm glad that I had the opportunity to do so. I was a part of the Mars Science Lab launch that went in 2011. And so seeing Perseverance land on last Thursday was, very exciting because we were a part of the precursor mission, and then seeing what happened in 2020 and 2021 was exciting. So I'm excited about what this next generation can do and just wanted to be a part of it. Speaking of which, I have to get ready for my next class. So thanks again. And I will be reaching out to you as a follow-up to today's event. But again, congratulations.
Thank you, Wanda. Thank you very much. And I see we have comments in the question and answer function. Thanks for such an informative session. Panelists shared so much in understandable terms. Much lessons seem to have been learned in the past 22 years, and much of the space era did get ushered in where South Africa is concerned. I happen to work for the other side of the space-focused activities at Astronomy Research Facility. This is from Simpiwe Majanga, and I imagine he's the Sarao man. Okay, there's a question from TV. Do you have a timeline when the curriculum policy will be revisited to fully enhance the knowledge of the space science and its importance? I think it's a curriculum-related policy question, Mutivi. It's from Memory Diza, and I think Memory is a teacher in Cape Town. Mutivi, do you want to take that?
Thank you. Thank you, Dan. Yeah, what I can confirm is in the next financial, which is beginning of April, we have made strides. We are now going to be engaging with both the Department of Basic Education and Higher Education with an intention of contributing towards a revision of our curriculum. So our intention, as you all know, some of you who are already at university or high school, we used to have subjects like, and I'm revealing my age, geography. So if you look at where some of these things comes from, we now need to see how visual aid can assist. So yes, it's a priority area. In the next financial, April onwards, we will be securing those sessions with the departments so that we talk about it. But I can't promise for this year, but it's a beginning topic. It's a continuation. Thanks, Dan.
Thank you, Mutivi. And it's good to also see that the geography curriculum from particularly grade 10 to 12 has remote sensing and GIS in it. And I know that geography teachers have expressed their interest to have space coming into their classroom over and above where it has permanent residence, which is the natural science, physical sciences with planet Earth and beyond, as well as many other intersections. Okay. In the absence of any other question, Dr. Munsami, perhaps just paint a picture for us in terms of what do you see coming on the horizon in the next 22 years of space exploration? I know it's a difficult question in view of all the changes happening, but I think you are the man for the job.
Thanks for your confidence, Dan. Just in terms of what's happening right here now, I think there's massive change that's happening. Especially inside of the agency, we're just currently just transforming. So we right at the cusp of changing our business model in terms of how we've been operating traditionally, with very limited focus on the industry, and changing that model to be more supportive of the industry. So all the growth that you're seeing that I showed in my slide is more about bringing industry into that value chain. So even today, we were talking about changing the Sansa brand to be more visible and more acceptable to the general public. And it's the little soft things that we are changing in the organization, even the values of the organization, how we're going to operate. And then you see ZASpaceInc has been established because we thought that was an excellent idea, that the industry sort of self-organizes. Then we can talk to industry in terms of having a listening post, so industry can have a chat to us in terms of how they see this relationship. Stakeholder engagement, how are we going to be doing that? And so what we're doing is trying to gear up for growth. And I think, when I first arrived at the agency, there was always this moaning and groaning, there's not enough funding. And I said, look, that's not your problem. The problem is that there is money. You just need to go and look for it and go after it. So we've put in a number of proposals into the system, and I think we've had a fair measure of success, and we're still trying. And so, and most of that is not just for Sansa per se, but for the industry. Human capital development is going to be a big part of this growth perspective. Outreach, where you're sitting, we want to see massive aspects. In fact, yesterday we were having a conversation about a new building for Sansa and having a science center inside of the new building in terms of where Sansa is going to be located. So students can come in, have a look and see of all the facilities that we'll be starting to look at. So I'm quite excited. And as I said, if the NASA Deep Space Network comes through, we'll be involved in future planetary missions from South Africa. And hopefully one day we could have a planetary mission of our own once we start growing in that direction. So I'm quite excited. Thanks.
Before you go away, Dr. Munsami, just hold on. I see there are questions and comments coming in the Q&A function. Makwena Mekwa says, it's not a question, but a compliment and a suggestion. I'm excited about the integration of space in the curriculum. Please don't leave primary school learners behind. So it talks again to that educational aspect. And I see Kaitano Dube from Valley University of Technology says, how far are we in terms of utilizing data from Sansa to achieve sustainable development goals as a country and as a region? I'll leave that one to you, Dr. Munsami. And then there's a comment from Tebu Habedi from the National Network of Science Centers. She says, good evening all. Thanks for such an insightful session.
I enjoyed this.
Okay, can you mute yourself? I'm reading the comments. Good evening all. Thanks for such an insightful session. This is from Tebu Habedi. Then it will be much appreciated if the recording could be made available. We celebrated the day with grade 7 learners of 2 primary schools. Due to COVID safety protocols, this aroused interest to the extent that all 6 focus primary schools would like to participate. So it is no more a day of celebration, but a week. Oh, wow, that is wonderful, Tebu's comment. So CEO, if you can tackle the question from Kaitano Dube on how Sansa is utilizing the data from space to achieve sustainable development goals as a country and as a region.
Yeah. No, thanks for that question, Dan. It's a good question. So we've signed up as a country to committing ourselves to the Sustainable Development Goals. There's 17 goals essentially. But if you had to unpack the goals, there's about 170 different targets and indicators that you have to achieve in order to achieve the Sustainable Development Goals. If you have to unpack those targets and indicators, at least 60%, if not more, of those indicators and targets actually require space science and technology. So let me just give you a brief insight in terms of how space impacts each one of us. So for example, if you drive in your car and you go, or if you on a school bus and you got a little phone like this and you looking at your GPS and wanting to know which direction you're heading, that phone or that receiver is talking to 3 or more satellites. Okay, it's triangulating. There's a bit of maths involved. Triangulating the signal, the timing signals that come from those satellites that gives you an accurate location. If you're looking at the weather report, that comes from a satellite. If you're watching live sport on TV, that signal, let's say if you're watching soccer, that comes from the sporting field to the satellite, which is 36,000 kilometers away, and comes straight to your home. So if you look at all your satellite TV dishes, they all point in the same direction. You go into a bank, you do an ATM transaction, it's going via a satellite. So our modern day lifestyle is dependent on satellites. So the quality of life and the economics, the backbone comes from satellites as well. So it's key to sustainable development, improving the quality of life, creating the economic growth for the country. If you take a sustainable development goal like climate change as an example, so we have what is called essential climate variables. At least 70% of those climate variables come from space platforms. They measure what's happening in the atmosphere, how much of pollutants are there. All come from space. You can't do that from the ground, essentially. So space science and technology is key, critical for sustainable development goals, including the National Development Plan. And so I think even last year or the year before, Sansa won an award for one of the SDGs in terms of the work that we're doing. This was a global recognition. So there's a lot we're doing, but from my perspective, I think we're only scratching the surface. There's still a lot more to be done in this respect. Thanks.
Thank you, CEO. I see the questions are pouring in as well as comments. And thank you, Wanda. I'm very happy to see a teacher who has spread the knowledge of space science. And we'd like to thank the panelists for valuable knowledge on space science. Very interesting presentations from Monique Potgieter and very inspiring. Thank you very much. Lebung Kabinde says, for university students studying geography and specializing in GIS and remote sensing, what kind of advice can you give us in order to grow in the sector? Thank you. So that's a question on GIS and remote sensing at university. Tabani Mazibuko from KwaZulu-Natal says, good evening, relevant and informed panelists. Main question is, how can we increase participation and ensure that space is linked to all economic sectors in South Africa, and that is just funded as such? Okay, so that's a question on linking space with other economic sectors in South Africa. And how are you with challenges of lack of science and science teachers, I guess? And yeah, we can take those two questions. I think any takers for the GIS and remote sensing at university level?
Yeah, Dan, it's Mutibi here.
Yes, Mutibi.
What I can contribute, I think the last question from KZN. One of the areas that I want us to look into, especially in South Africa, we have what you call the Integrated Development Plan, IDP.
Yes.
Now, it's going to be important if you want to influence change to identify how space can assist in doing some further planning. I mentioned the issue of municipality in terms of economic development. Now, those that are participating tonight, if you've got a background on geography, just the basics, I would encourage you that when IDPs are developed, participate in your wards, expose them and say, look, we are a rural village. Some of these things that we want to achieve in agriculture, especially when you look at development, space plays a very important role. Now, the minute you can introduce such kind of programs, it forces your wards or the ward councillors to put space as a program in your IDP, because if you don't have it, it must be a bottom-up strategy. So that will be my contribution on how we can influence the whole debate around space in South Africa. Then on remote sensing, I think it's more about the value. I always say that, when you drive cars, you've got all those tracking devices. We have the Googles of the world on our mobiles. I think as academics, even as students, we need to find a way of breaking down this, what people think it's very highly complicated subject. Bring at least, as professionals, you've heard what we are saying, and I'm sure many of you who are listening tonight, you've got other ways that you can, introduce this topic. So it's a movement. I always say that space has always been seen as purely weather service or spying. Now we need to start talking about the value. I think this is what all the panelists were saying. the value of space, it's the remote or villages. I mean, I said where you come from right now, how satellites have actually achieved to bring knowledge and communication. And it's not just remote sensing, it's satellite communication as well. So I just thought maybe let me bring the issue of community participation to expose some of those that don't know, especially in politics, because, you know, people always think that space, it's only to track people, but there's a lot that we need to start talking about. Thanks, that's my contribution.
Thank you, Mutibi. And yeah, I see the last question is relating to lack of science teachers. And perhaps with Wanda no longer on the panel, we have several initiatives on educator development. And I think majority from Tshwane South District, the leading district in South Africa in terms of performance, has alluded to not forgetting primary school children and their teachers, because that teacher development, those teacher development interventions are aimed at capacitating teachers to be comfortable with such topics as planet Earth and beyond. And in high school, geography teachers with GIS and remote sensing, getting the learners to touch, to do things, to do measurements, to actually compare satellite images, one satellite image, many applications. So Peter Sibake's comment says, interesting presentations and inspiring. Thank you very much and appreciated. And I think, yeah, this is the last comment that we have on the Q&A. I'll give the panelists, as we wrap up, the last opportunity for closing remarks. I'll give you 30 seconds to just make closing remarks, noting that Sunsat was the main star of today's show, but its launch was even more significant, going into space, making South Africa an African spacefaring nation. And of course, culminating into the creation of an environment in which the need for a space agency was created and led to its establishment. And now it is about to celebrate 10 years in existence. And of course, the space industry seems to be expanding, with companies in ADCS technologies sent overseas, exporting components and subsystems. I will start with Professor Sias Mostert. Parting shot, Prof.
Thank you, Dan. I am really excited about the fact that I can see that after 30 years of being involved in education, it really pays off. But it also is a demonstration of it's a 30-year journey. It's not something that happens overnight. And South Africa can be proud of the fact that it's got so many space engineers that are not only active in South Africa, we also have exported some engineers that are extremely active in the US, which are changing the face of space. So all success to Sansa for the next 10 years. We are keen supporters of the efforts.
Thank you, Professor Mostert. And Dr. Munsami, let me leave you for last. Ndate Ramusi, parting shot for the audience.
Yeah, my parting shot is never give up. I think we all know the value of space. We need to continue to promote and talk about its relevance to human development and economic development. And the big issue is try and see whether any visual aid, if you want to use it as a decision-making program, how can then space assist you? And the other big issue is how we communicate this particular program of space. I mean, having worked with Val, with Dr. Prof, and yourself, Matsapola, in South Africa, it's about the language. How do we communicate this? Let's not make it very complicated. Let's not make it very simple, but make it relevant to all the programs that we want to achieve. And again, make sure that we speak space in Sepedi, in Zulu, in Xhosa. And if we do that, it brings those that think that they are not part of the game. So for mine, and especially with people with disability, it's becoming very important. So what I would advise us as a collective, because we're celebrating, let's go to the broadcasters, both radio, television, and let's start talk about space and show them how space is impacting and contributing to our life. But thank you very much for this. I'm proud and I'm happy for what Sansa has done. Well done. Thank you.
Thank you very much. And I'm going to leave the last comment for Dr. Munsami. By the way, this is how we joke with Dr. Munsami because, you know, he used to be in government and wrote the policies that created a context for the creation of Sansa. Then he came down. So when we joke, we say, for government so loved space that it gave us its only begotten son, that whomsoever believes in him will migrate from millions of rands in funding to billions of rands in funding. So Dr. Munsami, closing short.
Yeah, I said you have to be careful because you'll get me involved with the man upstairs. So just to a parting shot, I mean, space incites and it inspires. It grabs your attention and it's a good conduit to promote science and technology. I don't think there's any other domain like space science and astronomy that comes anywhere close to those two disciplines. Just to give you a bit of context, in Sansa, we have two programs. One is space science. It was established in 1941. The space operations was established in 1960. And those are now giving rise to new opportunities. Like we're building the most advanced space weather center on the continent. And in fact, next month, we're starting the construction. We're going to build a new site for space operations. We enter into the space domain for the long haul. It's not a short-term view, okay? Because we look at decades in terms of horizons, you and I, the likes of you and I and Prof. Sias and Motibi, we are here today, but we'll be gone tomorrow. So we need new people to come in, step into our shoes. So we're looking to the new generation that are represented here today to actually step up. And so we're quite excited that there are people that are there and that's going to take the country forward from where we left off. Thank you.
Thank you, Dr. Munsami. And let me just say thank you to all the panelists for your enormous contribution that you've made, the jewels you've shared with South Africa and the African continent. Thank you very much. And last but not least, thank you to SciFest Africa for providing Sansa with the platform to share this wonderful enthusiasm about the burgeoning and ever expanding space science and technology. With that, I would like to end this session on space awareness targeting Africa's 420 million youth aged between 10 and 35, the real future. Thank you very much.
Thanks, Dan. Thank you.
Thank you, Dan. Thank you very much.
Thank you, Dan.